Okay, let's continue. Okay, so here we say if in we say in variable in variables are theta. Okay, now this limit is what? Okay, so that's equal to this. The limit is equal to, say, from alpha to beta, and then from A to B, and F or cosine theta or sine theta or dr d theta. Okay, so if you treat as the integrand as the function, okay, you treat this whole thing, okay, as a function of r theta, okay, of r theta. So you look at the previous limit, that's a limit of Riemann sum of a new function. Well, your book call it g of r theta. Okay, g over r theta. So g over r theta, dr d theta. So that's equal to this. Therefore, we have this. Okay, we have this formula. Therefore, we say if f is continuous on R, and this is a polar rectangle R theta, we say A, R is between A and B, theta is between alpha and beta. Okay, where we assume this theta minus alpha is less than equal to 2 pi, okay, less than equal to 2 pi, okay, because we don't want the angle be larger than 2 pi, okay, and then now you see if we have this then we say this integral R f x y dA is equal to alpha to beta, A to B, f or cosine theta, or sine theta, or dr d theta. Okay, now it looks like the right hand side is more complicated, but in fact, if R, the region, is related to a circle or part of a circle, and then when we change to the right hand side, actually a lot of times it's much easier. Okay, let's look at it at the first example. Let's say example 1. Okay, I will say find the volume. Find the volume of the solid. Bounded by, here we have a z equal to 6 minus x squared minus y squared, and z equal to 2x squared plus 2y squared. Okay, if you look at those two surfaces, both are paraboloid. One is open down, one is open up. Okay, so well, let's draw the graph first. Okay, so here we say this is the axis. Now you see the first curve, when x equal to 0, y equal to 0, z equal to 6, so 0, 0, 6. Okay, and then let's see. Here's 1, 2, 3. Okay, about say this point. Okay, now you see when you think about it this. Okay, so here let's look at it this. Well, because those two surfaces form a boundary of a solid. Now let's see where those two vertices intersect. So if you solve this the system equation, say z equal to 6 minus x squared minus y squared, z equal to 2x squared plus 2y squared. If you set up z equal to each other, and then you're going to have what? 2x squared plus 2y squared equal to 6 minus x squared minus y squared. So you move the x squared y squared to the left hand side. You will have a 3x squared plus a 3y squared equal to 6, which means x squared plus y squared equal to 2. So this is well, when x squared minus y squared equal to 2, then z is equal to 4. Okay, z is equal to 4, and then now you see here 6, 4. So that means they intersect at z equal to 4. Okay, about here, and the radius is a root 2. Okay, so it's a circle. Okay, like that. And then suppose this is a y-axis, this is a x-axis, and then so the top one is open down, is like this. Okay, and the bottom one is open up, is like this. Okay, so we say here is a 4. Okay, now we say this surface is z equal to 2x squared plus 2y squared, and the top surface is z equal to 6 minus x squared minus y squared. So this is x, y, z. Here's the origin. Okay, now if you look at this intersection, if you projected this down to xy plane, so you're going to have a planar circle, and then we say, well, this is planar region. Okay, planar region. Now if I call this R, okay, so we say, well, this R is equal to, so if you use a polar coordinate, that's very easy to describe, the R theta. And then, so here, well, this is equal to root 2 squared, right? So that means the R is changed from 0 to root 2. And then theta change from 0 to 2 pi. So that's this one. And then when we consider the function, okay, so if we consider function f, say here we say f x, y, so that's equal to what? That's equal to the upper surface minus the lower surface. Okay, you can think of you find the volume below the top surface minus the volume below the second surface. So that means it's like a 6 minus x squared minus y squared minus, here is a 2x squared plus 2y squared, right? So this is equal to 6 minus 3x squared plus y squared. equal to that. Okay? Equal to this. Okay. Now, if you consider this volume is equal to R f x y dA. If you change it to polar coordinate, so that's 0 to root 2, and then 0 to 2 pi. Well, when you put it x equal to r cosine theta, y equal to r cosine theta equal to x squared plus y squared, that's just equal to what? Equal to r squared. And then here's the rd theta. Okay, so that's equal to this. Okay, now, well, you see this, this has nothing to do with the theta. Okay, so that means you can say this is 0 to 2 pi d theta times here is 0 to root 2, and then 6r you have 3. Okay, well, I think I'm going to put it, still do one more step. Okay, so here is a 6r minus 3 r to the third dr. So this is equal to 2 pi times, here is a 3r squared minus 3/4 r to the fourth. Plug in root 2, 0. Okay, now root 2, put it in the first term, 2 pi, and then that's equal to 2, that's 6 minus second term, okay, root 2 to the fourth is 4, so that's equal to 3. And then, so this is the 3 times 2 pi is equal to 6 pi. So that's the volume. Now you see this one, you can try, if you don't use a polar coordinate, it's going to be much harder, okay? Now let's look at the second part. Okay, how about we say the polar region is not rectangle, polar region of the form. Okay, how about we use this type of a region? So this is r theta, and then we say theta change from alpha to beta. Okay, so that means the theta between two constant angles, and then r between two functions, h1 theta to h2 theta. Okay, we say it's like this. So for example, okay, when we draw the graph, say here, how about we say like this? This is the polar axis, and then, well, okay, so here we say, well, maybe the curve looks like this. Okay, so this is like a D, and then here is alpha, and then here is beta, and then we say this curve is r equal to h2 theta, and this curve is r equal to h1 theta. Okay, r equal to, so it's like this. So the region is like this type of region. Okay, this type of region. Then we say if f is continuous on D, then we have this. So if you want to integral fxy on D, so if you change to polar coordinate, so this is alpha, beta, and then we say this is h1 theta, to h2 theta. And then, well, we replace x by r cosine theta, r sine theta. Okay, always remember there's a r d theta, because r d theta is the dA, that's the area. Okay, so we have this formula. Now let's look at example 2. Example 2. So we say evaluate. So here we say okay, so we want to evaluate this double integral of x over d. D is the planar region in the first quadrant, lies between two curves. Well, if you look at it, those two curves, that's just two circles. Okay, so here let's see solution. So we have, say here, if you look at it, x squared plus y squared equal to 2x, this implies we have x squared minus 2x plus y squared. If you add 1 to both sides, so this is the x minus 1 parenthesis square plus y square equal to 1. Okay, now this is a, if you draw the graph, okay, if you draw the graph, the first one is if you look at x squared plus y squared equal to 2 squared. Okay, so this is suppose we have this is a 1, 2, and then here is a 1, 2. So that's in the first quadrant. So this is the quarter of a circle. Okay, so that's this one. This is x squared plus y squared equal to 2 squared. And the other one, well, this is the radius is at this point, the center at this point, the first equation, and the radius is a 1. Okay, so we're going to have this circle, okay, as a half circle. Okay, it's like this. And then we say, well, this one, this is say x squared plus y squared equal to 2x. And then, well, we say in the first quadrant, okay, we say, well, this is D. This is a D. Now we know if you change this to polar coordinate, this one just r equal to 2. And this one just r equal to what? 2 times cosine theta. Well, if you plug in left hand side r squared, right hand side is 2r cosine theta. R cancel one of them. Okay, so that's so here's 1, 2. Okay, so that's a polar coordinate. Okay, that's the region. And then we say, well, so the integral is equal to, we say the integral, we say dx dA. So this is equal to, say 0 to 2 pi, 0 to pi over 4, pi over 2, 0 to pi over 2, okay? And, well, notice that even they are equal to 2 cosine theta, even the half circle as theta change from 0 to pi over 2, okay? And then the second, yeah, I think I probably should write the d, describe the d first in the polar coordinate, so r theta. So this is, say, theta change from 0 to pi over 2, and r change from 2 cosine theta to 2. So that's the d. Okay, so this is 2 cosine theta to 2. Well, x is equal to r cosine theta, and then r d theta. So we need to have put it r d theta. So that's the integration. And then this is not very hard to evaluate. So here we say this is 0 to pi over 2. And then, so here we say you first of all integral with respect to r. So you have a cosine theta put out. R times r squared, so it's 1/3 cosine, 1/3 r to the third. R to the third. And then plug in say here's a 2 cosine theta, d theta. Okay, and then this is equal to, so you plug into, well, 2 can say 0 to pi over 2 cosine theta. And then, so here, this is 1/3 we can move out. Well, both terms have the 2 to the third is 8. I can put out 8. And then we have 1 minus cosine third theta, d theta. Okay, so we have that. And then now here we say a third will move out. The first term is cosine theta, okay? The antiderivative is sine theta, plug in pi over 2, 0. And then minus, now this is, say 0 to pi over 2, cosine to the fourth. Cosine to the fourth, we can put it like cosine square and the square. Cosine square is 1 plus cosine 2 theta over 2 d theta, right? Because I have a cosine 2 theta is equal to twice a cosine square theta minus 1. You add 1 both sides, divide both sides by 2. Okay? And now this is a 8/3, and then here's a 1 minus. Now here, when you take a square, so you're going to move out 1/4, and then integral 0 to pi over 2, and then we have a 1 square is a 1 plus 2 cosine 2 theta plus cosine square 2 theta. right? D theta. So we have that. Now this is equal to a third minus 2/3. Okay, we multiply through, and then here, well, this is a theta, so pi over 2, and then this one you're gonna have plus sine 2 theta, When you calculate derivative, the 2 use chain rule 2 move in front, and pi over 2, 0. Now both terms equal to 0, so this one will be 0. Okay, and then this term, this term is we're going to use the double angle formula again. So this is equal to 1 plus cosine 4 theta over 2 d theta, right? Okay, so we have this a third minus pi over 3, and then so negative 2/3 times 1/2 move out, so negative 1/3, and then pi over 2. Okay, then plus, let me see, I already move out the half, so cosine, so that means 1/4 sine 4 theta, plug in pi over 2, 0. Now this term again equal to 0. Okay, so that means we're going to have this is equal to 8/3 minus pi over 3 minus pi over 6. Okay, so that's equal to 8/3 minus pi over 6. Sorry, both are negative, so that's equal to pi over 2, right? So that's minus, this is a 2 pi over 6 minus a 3 pi over 6 pi over 2. If you combine, well, you can leave it like that, say 6. So that's a 16 minus a 3 pi. Okay, so that's equal to that. Okay, and then what we say, let's look at another example. Example 3, we say evaluate this one. We say here integral from 1/√2 to 1, from root 1 minus x squared to x, xy dy dx, plus 1/√2, 0 to x, xy dy dx, and then plus from √2 to 2, and then from 0 to √4 minus x squared, xy dy dx. Now if you want to integrate this one by one, and then that's not going to be easy. So here what we are going to do, well, let's first of all look at it, the region. Okay, the region D, we say has 3 parts. Okay, so we can put it like the D is equal to D1 union D2 union D3, where we say D1 is equal to the first one, so we say xy And then we said this is a 1 over root 2, x between 0 and 1 over 1 to 1 over root, x between 1 over root 2 to 1, and y between 1 minus x squared and x. So that's D1. Now you see D2 is equal to, say here is xy, and then D2 is, so we have x is between 1 and root 2, and y is between 0 and x. And then D3 is xy between root 2 and 2, x between root 2 and 2, and then y is between 0 and root 4 minus x squared. Okay, now if we draw the picture of it, let's see what this looks like. Okay, in the rectangular coordinate system. Okay, so if you look at this. Okay, first one is, well, you see we have y equal to x. First of all, let's look at y equal to x as this line. Y equal to x. Okay. Now, y equal to root 1 minus x squared, which is y squared equal to 1 minus x squared, or x squared plus y squared equal to 1. So that means that's a circle. So here we say, well, how about we draw this circle with a radius equal to 1. So this is a 1. Now, when x equal to y, this is exactly 1 over root 2. Why? Because x equal to 1 over root 2 is square is half. And y equal to 1 over root 2 square equal to half, added together equal to 1. That's exactly intersected here. Now, if you look at this, when x change from 1 over root 2 to 1, 1 over root 2, 1, and y change from root, so this is y equal to root 1 minus x squared to x, y equal to x. So that's exactly this part. So that's equal to this region, right? That's D1. Okay, so here, how about I'll use a different color to put D1 here, D1. Okay, now from 1 to root 2, okay, root 2 is a 1.414, okay, so here is a root 2. And then, well, here, x change from 0 to, okay, so we're going to have, this is a, okay, that's D2. This is the D2. Okay, that's D2. Now, then you look at it here when x equal to root 2, y equal to root 2, says root 2, root 2. Root 2 squared is 2. And then when you, yeah, I think I say here, now you see, well, how about I'll just draw this one. So here, that point is on the circle x squared plus y squared equal to 2 squared. So you see, this one is equal to y equal to root 4 minus x squared. Okay, and then you see here, this is a 2. And then we say, well, that's D3. Okay, so you say this is a D3. Now, you see, if you use a polar coordinate, so then therefore, well, we say therefore D is equal to, so if you use r theta, and then we say, so here is, well, you can, this is a polar rectangle. You can describe r, you describe, so we say r is between 1 and 2, and then the theta is between 0 and pi over 4. So you see, if you change it to polar coordinate, it's fairly simple. And then we say, well, now we say this d x y dA is equal to, so 1 to 2, and then 0 to pi over 4, r cosine theta, r sine theta, r d theta. Okay, so this is equal to, okay, so we have 1 to 2, integral with respect to theta first, so r is like a constant, r to the third and move out, and then theta, well, this is a cosine theta, sine theta, so you have a theta sine theta as equal to half sine square theta. Okay, so you plug in pi over 4, 0, dr. And then plug in pi over 4 equal to root over 2 squared equal to half. So that's equal to 1/4. Okay, 1/4. Right? And r to the third antiderivative 1/4, r to the fourth, plug in 2, 1. Okay, so, well, 2 to the fourth is 16 minus 1, 15. So this is equal to 15 over 16. Okay, so sometimes when we have a complicated integration, you have several terms. So if you study the region, and then if the region can be, you think about it as form the part of a circle, and then you can easily describe as a polar coordinate, and then the integration comes easier. Okay, so this is the section 15.3. Okay. Okay, so that's 15.3, and then so, well, basically we remember the formula. Okay, the one is on the polar rectangle, another one is not a rectangle, but theta is between constant, r is between two functions. Okay, both we have a formula. Okay, you plug in x equal to r cosine theta, y equal to r sine theta, and then dA is r dr d theta. Okay. Remember the formula. Yeah, a lot of times draw the picture, very helpful. Okay, please read this section and do the problems. Okay, I'll talk to you next time. Bye bye.